In section 1.4, we are going to be talking about using compositions of functions to create a new function. So first I want to just do an example of why compositions of functions are valuable, and because they can really be time saving if you're doing multiple operations over and over. Again, especially in like business, this happens a lot when you're calculating a lot of stuff. So in this example, we have a construction worker. It says, you're a construction worker who builds decks on the side for extra money. You only make rectangular desks. You determine how much your lumber will cost you based on the size of the deck. And then you charge your customers $1,500 plus 140% of the cost of lumber. So you figure out how much the lumber is going to cost you, and you tack on an extra 40% fee because you are a business. And then it says the current going rate for lumber is $12 per square foot. So what would generally happen is you would put an ad out, whatever, somebody would call you and they would want to know how much it's going to cost for you to make this deck that they want. So you would end up asking them what size deck they want. Remember, you only make rectangular decks. So maybe you have maybe they want a 10-foot by 20-foot deck. So then you just multiply those together to figure out that their deck is 200 square feet in size. So now you have the area of the deck. Okay, so that's one thing. Then you would need to figure out how much the lumber is going to cost you so that you can figure out what you're going to charge them. So the cost of lumber, it says the going rate is $12 per square foot. So you would multiply those together to get your $2,400 that it's going to cost you to buy the lumber for this job. So then you would calculate what you're going to actually charge the customer. So that was going to be $1,500 plus 140%, which 140% as a decimal is 1.4 times the cost of that lumber. So then you would just calculate this out. So 1.4 times 2,400 is 3,360. Add those together and you'll get the cost for your customer is going to be 4,860. So then you would call them back and you'd let them know the bid or the estimate, and then they would decide if they wanted you to build their deck or not. So if you're doing a lot of these, if you're ending up with a lot of people calling you, asking you to price out a deck for them, you're going to have to keep calculating this multiple times, right? So calculating the cost of lumber, plugging it into the formula, doing all of these. So if you could simplify that process, and now this is a pretty like simplistic idea here of just a rectangle, but if you could create a new function that only needed one input, then you could calculate this faster, saving yourself time. Time is money in business. So that would be a really good thing. So we're going to get into actually creating new functions in the next video. In this one, we're just going to work on like plugging things in and specific values. So let's take a look at the notation for compositions of functions. Okay, so it's denoted by this little thing with this little open circle. So a lot of times you'll see it like this, f of g, or those could be any letters. F is a function, g is a function, it could be anything. And so it's read f of g. So you read this little open circle thing here as of. And then this is the rule. Okay, so f of g of x equals, and you write it like this, where you have g of x being plugged into f. So let me put some colors here. So you've got this g of x function, and you're plugging that function into f, taking the whole function and putting it into f, into the other function. So if you had other ones, let me just do a different with some other letters. Like you could have a of b of x, and then that would be written like this. You'd have the a function and you'd be putting the b function into it. So you'd have the b function inside of the a function. So what does this even, look like? So let me show you this little meme to try and help you figure out what we're doing here. So if f of x is bread, okay, bread or toast, so we see this bread right here, and then g of x is eggs, okay, so if we were going to do f of g of x, so you see the g of x function inside of the f of x function. So remember, the f function is bread, the g function is eggs, so we're putting the eggs into the bread. Okay, so we're taking the eggs and we're putting it into the bread, making an egg sandwich, right? If you're doing g of f of x, okay, so if you're doing the g on the outside and the f function is on the inside, remember the f is the bread. Now you have bread in between eggs. Okay, so now you have eggs on the outside and bread on the inside. And you can kind of see that, like bread inside of an omelet or something, right? So we've got one thing on the inside going into the outer function. So let's take a look at kind of how we do this. So I want to do this specific example here. So our f function is x squared. Our g function is the square root of x plus 1. So initially here, I want to plug in f of 2 into g. So I would read this g of f of 2. So what we're actually going to do, like you can calculate f of 2 first, but I want to kind of write this out. So I want to go to this g function over here, okay? And I want to, so g is the outer function, right? So we have this input x. And now what we're doing is we're plugging f of 2 into there. Because now instead of this, okay, instead of an x, now we have f of 2. So I'm going to plug f of 2 into there. So wherever you see x in the g function, you're plugging in f of 2. So let's calculate what f of 2 is so that we know how to do that. So f of 2, take the f function here and plug 2 in. Okay, so the f function is the input squared, input being 2 this time. So f of 2 is 4. And then we just plug that into the g function, right? So right here, f of 2 we now know is 4. Okay, so when you plug in 4 into the g function, because f of 2 is 4, so plug it in. 4 plus 1 is 5. So you have square root of 5. So you're going to take f of 2 and plug that into g. So let's look at a couple more examples here. Okay, so our two functions are f of x equals x squared minus 3. Okay, so the input squared minus 3. And then g of x is equal to the square root of some input plus 1. So let's take a look at this first one. Okay, so notice that the g function is the outer function. So I'm actually just going to write that down right away. Okay, because we're taking something and plugging it into the g function. So what are we plugging into the g function? F of 0. Okay, this is going into the g function. So we're plugging in f of 0 here. So figure out what f of 0 is so that you know what to plug in. So off to the side here, I'm just going to calculate f of 0. So that's 0 squared minus 3. 0 squared is 0, minus 3 is negative 3. So f of 0 is negative 3. So this chunk is negative 3. So now you just simplify this. So the square root of negative 2, because negative 3 plus 1, which is actually undefined. You can't do the square root of a negative number. So the answer to this, okay, you would just say is undefined. So g of f of 0 is undefined. And that's because this has a restricted domain, right? Because square roots, you can't do the square root of a negative number. So if x is ever less than negative 1 here, you have failures. Okay, so negative 1 to infinity are the only numbers that are going to work in there. Okay, let's take a look at the next one. I'm going to get some more space here. Okay, so let's take a look at this one. So now our outer function is the f function. So we're going to be plugging g of negative 1 into that. Okay, so I'm going to write down the outer function first. Okay, so I'm going to write down the f function, which is an input squared minus 3. The input in this case, what we're typing in is g of negative 1. Okay, so what we're putting in is g of negative 1. So we need to figure out what that is, because we can, because it's an actual number for negative 1. Okay, so off to the side here, I'll do g of negative 1. Remember, the g function is an input plus 1. Okay, the input in this case is negative 1. Negative 1 plus 1 is 0. So g of negative 1 equals the square root of 0, which is 0. So what we're actually doing here is f of 0. Okay, so then we've got that squared minus 3. So 0 squared minus 3. 0 squared is 0, minus 3 is negative 3. So this answer right here simplifies to negative 3. So we plug it into g, in negative 1 into g, take that answer, plug it into f to get our overall answer. Okay, one more. This time we're just doing f of 3. So let me pull this f function down here for us. Okay, because we're just going to plug into the f function here twice. Okay, so I'm going to again take this outer function and write it down. Okay, so the f function, okay, is something squared minus 3. And then I'm gonna write this whole thing as green so we can see it. But when we what we're plugging in is f of negative 3 into there. So figure out what f of negative 3 is, okay, which is negative 3 squared minus 3. Negative 3 squared is 9, minus 3 is 6. So f of negative 3 is 6. And then simplify. So 6 squared is 36, minus 3 is 33. So f of negative 3 is 33. So plug it into the f function, okay, get your answer, and then plug it back into f. So then take that, put it right back into the f function. So work your way inside out. All right, then I just want to take a look at what that looks like on a graph as well. So we're going to take a look at this g function because we're going to work our way from the inside out. So this says f of g of negative 1. Okay, well here's g of x. Okay, so what we need to do is figure out what g of negative 1 is from this graph. Okay, so this is your x value. And then you're figuring out the output or the y value. So go to x equals negative 1. What's the y value? Looks like 1. Okay, so g of negative 1 is 1. So now what we're doing here is f of 1 will finish off our problem. So then we're going to go to the f function, plug in x equals 1, and figure out what our output is. Output meaning y value or height. So we're going to get 4. So f of g of negative 1 equals 4. Plugging negative 1 in, figuring out the output, taking that output, plugging it into the f function.